Hello class and welcome to lesson 3.1. We're starting our third unit in our course and we're dealing with vectors. So what we need to do is introduce in 3.1 the difference between what's called a scalar quantity and a vector quantity. All right, so here's a couple definitions. A scalar is a quantity that describes a magnitude. So, for example, 14 degrees Celsius or 18 centimeters. Notice that there's a unit of length or a unit of measurements here. Okay, that describes a magnitude, okay, or a quantity of something. A vector, however, is a quantity that describes both a magnitude and a direction. So for example, velocity of 80 kilometers per hour east. So again, we have the magnitude, which is your speed, which is kilometers per hour, and then your direction, which is east. Okay, that makes a vector. Okay? And we're going to learn about vectors and how to draw them and how to add them and subtract them throughout this unit. So it's important that you get a basic understanding of what a vector is and how to draw it. Okay, a vector can be represented by a directed line statement. Okay, that's an arrow on the tip indicates the direction and the length indicates the magnitude. Okay, the magnitude is positive despite its direction. So what we have to do is realize that vector AB has a magnitude of the absolute value of AB, because depending on which direction you're going, length, for example, can never be negative. Okay, just remember when you're drawing it, basically the tail is where you start. Okay, and the tip is kind of where you're going or your end. Okay, and that gives us the direction. So in this case, we'd be going somewhere northeast. Okay, we can use words to describe it. So a force of 2.2 newtons on a bearing of 5 degrees, or we can use symbols, and we always put the magnitude first. So we're going to write magnitude first, then direction. Okay. So if you see short forms or symbols, it's always going to be magnitude first and then direction. I would like you to pause the video right now, ladies and gentlemen, and click on some of these videos or copy and paste them and try them. I really like the Angry Birds one. That's kind of fun. Takes about 12 minutes. And then I also like the football one. So I thought this was a good analogy for you guys to introduce vectors and how you can actually see it in our everyday life. So please pause the video and or my lesson and click on these and watch these, or copy and paste them out into YouTube and watch them. Okay, welcome back. Hopefully you enjoyed those videos. Now we're going to take a look at some other terminology. The next terminology we want to talk about is what's called equivalent vectors. Just think about equivalent or like terms, okay? Back from grade 10 and 11. Okay, equivalent vectors have the same magnitude. That means they're going to be the same length and the same direction, which means they have to be pointed, or the arrow has to be going towards the same direction. Okay? Opposite vectors have the same magnitude, i.e. the line is the same length, but are in opposite directions. Okay, so in this case, this one's traveling. In the first case, this is traveling west, and my apologies, it's traveling east, and in the second case, it's traveling west. All right, now let's do a little bit more about the direction, because there are two different ways. Hopefully from trigonometry you remember how to do some of these, but otherwise we'll discuss two different ways to do direction. The first one is what we call a bearing, or true bearing. Okay, and that's the angle measured clockwise from north and expressed as a 3-digit number. So for example, if we have north, east, south, and west, if you're looking for degrees, this north starts 0 degrees, east has 90 degrees, south has 180 degrees, and west has 270 degrees. Okay? All right. A quadrant bearing is the angle of 0 to 90 degrees, which is measured either east or west of the north and south. So this is probably the one you're more familiar with. North 22 degrees east, or south 24 degrees west. Okay. So let's take a look at this example here. Okay, the bearing is 160 degrees. So from my north, I start here at 0 degrees. I move my arrow to 160 degrees. Remember, east is 90 degrees, so it's got to be greater than that. And south is 180 degrees. So the difference between those two angles is 20 degrees. Okay? And if we start with that, that's a bearing of 160 degrees. Now to find out how to put it in quadrant bearing, you take a look, hey, am I closest to north or south? Well, we're closest to south here. Okay, and how many degrees off am I? I'm 20 degrees, and what direction am I? 20 degrees east. So the quadrant bearing is south 20 degrees east. Okay. So that gives you the quadrant bearing and the true bearing. All right, let's do some examples on the next page, see how we can do. Okay, draw a vector with a displacement of 2 centimeters west. So first of all, we're going to start with our tail. We're going to get our ruler out and we're going to measure 2 centimeters and we're going to go in the west direction. Okay, so draw it 2 centimeters going west. All right. Our last example before we do our homework is to describe the vector in words. Well, first of all, what do we know about this? This is given 120 degrees, so this is a bearing measurement. So we have a bearing of 120 degrees. But now let's try putting in the quadrant direction bearing, okay? So let's put it in the quadrant bearing. So what do we realize? First of all, this angle is closest to south, but we need to figure out, hey, how far away from south is it? What do we know? We need to take, we know we're 180 degrees at south, and we've got to subtract our bearing, which is 120 degrees. So that's going to get us 60 degrees. So that angle closest to the south is 60 degrees. So when we're taking a look at our quadrant bearing, it's going to be south 60 degrees east. All right. Let's take a look at our second example here. Well, if we want to do the bearing, remember we start at true north and we go all the way around. Okay? We don't have an actual bearing value given. We have a diagram that could be closer referred to the quadrant bearing. But let's do the bearing one anyway. To go all the way around, folks, it would be 360 degrees, right, to complete one circle. So how do we figure out the difference? You're going to take 360 degrees, subtract that quadrant angle, which is 45 degrees. You're going to get 325 degrees. So therefore, we are at a bearing of 325 degrees. Now to do our quadrant bearing, ladies and gentlemen, again, that angle that we need is given, so we already know it's 45 degrees, but we just have to know in which way or which direction is it from north. So hopefully you would notice that it's north 45 degrees west. All right, so here's your homework, ladies and gentlemen. Again, if you have not taken a look at those videos, please do so that were posted on the first page. Here's your homework, page 45 and 46, numbers 1, 2BC, 5AB, 6AB, 7AB, 12, and 14. Have a great day, and again, see me if you need any extra help. Goodbye.